My name is Bernd Lenzner. I'm a senior scientist at the Department of Botany and Biodiversity, and my main field of expertise is understanding global environmental change drivers and their effects on biodiversity and society, particularly biological invasions.
My name is Johannes Wessely. I'm a senior scientist at the Department of Botany and Biodiversity, and my main field of expertise is modeling future distributions of species with a main focus on climate change and plant species. Did you know that terrestrial biodiversity affects almost all facets of our lives, from drinking water quality to infant mortality? In this video, you will learn about the main causes of terrestrial biodiversity loss and their significant effects. You will understand how human activities have increased the rate of species extinction and examine specific human threats to biodiversity. With examples of climate change in mountain regions and the introduction of alien species, we will show how biodiversity loss affects both ecosystems and human health. You will also learn about the tools and policies that can help mitigate and possibly reverse biodiversity loss. To get us all on the same page, biological diversity or biodiversity describes the diversity of life, from genes to ecosystem. This means it describes the diversity within and among species, as well as of ecosystems. Since the mid-19th century, due to increasing human impacts around the globe, more and more pressure is put on species and the populations. As a result, more species are becoming threatened, which is also reflected in increasing extinction rates. To give you an idea, anthropogenic extinction rates are currently up to 100 times higher than what we would observe naturally. But what drives these anthropogenic extinction rates, and what consequences does the loss of biodiversity have? The World Biodiversity Council, IPBES, has identified 5 main drivers of biodiversity loss worldwide, namely land use change, direct exploitation, climate change, pollution, and invasive alien species. We will introduce 2 of them to you in more detail: climate change and invasive alien species, and how they affect biodiversity as well as humans and society. Let's start with the effect of climate change on biodiversity in mountain regions. First of all, it is important to note that mountain regions are hotspots of biodiversity. In Europe, alpine areas cover only 3% of the surface, but harbor about 20% of all vascular plants native to Europe. Therefore, mountain regions are of special interest to study and protect. But let's take a step back and talk about the effect of climate change on species. As the climate warms, species have to follow suitable conditions. This shift is already well documented for the past. As you see here, there is a fast shift towards the poles and up the mountains. But for many species, suitable climatic conditions are shifting too fast and they struggle to keep up with the rapidly changing conditions. This means that species ranges are shrinking, which eventually results in local extinctions of species. For mountains, these range shifts are especially problematic. Species have to move upwards and at some point face a nowhere-to-go situation as they reach the mountaintop. Therefore, extinction rates are predicted to increase for alpine plants under future climate change. Simulations show that half of the plants we find in alpine regions will lose more than 80% of the suitable habitat. But why should we care? Let's think about it in a global context. Intact mountain systems are crucial for diversity, from genes to species, and for providing nature's contributions to people like carbon sequestration, stabilizing soils, and water regulation. For example, the Central Andes harbor around 4,300 varieties of potatoes, genetic diversity that could get lost. And to stay more local, the biodiversity of the Rack-Schneeberg mountain region southwest of Vienna absorbs and filters our daily water that arrives in Vienna via the Vienna Mountain Spring Pipeline. To reduce the impacts of climate change on this diversity in mountain systems, potential measures include the implementation of sustainable land use practices, establishment of conservation areas, and targeted education and awareness programs.
Let's change topics from climate change to invasive alien species. Worldwide, there are over 37,000 alien species, of which 3,500 are known to be invasive. Alien species are those that have been brought somewhere by humans where they would naturally not occur. So-called invasive alien species are defined to have negative effects on biodiversity, nature's contributions to people, and good quality of life like health. When looking at the impacts on biodiversity, invasive alien species are known to have contributed to over 1,200 extinctions of native species worldwide, particularly on islands. These impacts on native biodiversity are mainly caused by three mechanisms: competition, predation of animals and herbivory of plants, and ecosystem changes. As mentioned, by threatening biodiversity and the natural balance of ecosystems, invasive alien species can also negatively affect humans and society. Here's an example how this can happen. The white nose syndrome found in the bats in North America. White nose syndrome is caused by an invasive fungus that affects bats and leads to populations decline and potentially their local extinction within 5 to 6 years. A recent study has linked this decline in bats to an increase in insect pests. Farmers in turn reacted to this pest increase by applying more insecticides to protect their yields. However, this higher insecticide concentrations resulted in higher infant mortality. So overall, we can see indirect impacts of invasive alien species on humans through their negative impacts on local biodiversity and the erosion of essential ecosystem functions. Just to give you an idea of the economic impacts, since 2019, invasive alien species have cost us over $423 billion globally, and this cost is currently quadrupling every decade. While these numbers and negative effects seem overwhelming, there are things we can do to reduce the impacts of invasive alien species. As in most cases, prevention is key. If species are not introduced, they cannot become invasive in the long run, something we call precautionary principle. For that reason, countries are investing in prevention, early detection, and eradication of introduced alien species populations, a method that is also saving a lot of money, as management in the early phases is much cheaper than later on.
Coming back to our questions from the beginning, you have seen that biodiversity is more than an abstract construct. It is directly linked to us humans and our livelihoods. For example, climate change in mountainous regions influences drinking water quality and availability, and the introduction of an invasive alien species illustrates how the loss of biodiversity and erosion of ecosystem services can result in downstream negative effects on humans. The main drivers of biodiversity loss, namely land use change, direct exploitation, climate change, pollution, and invasive alien species, are all human-made. Accordingly, besides being the major threat to biodiversity, we also are part of the solution.
Already today, there is a wealth of policies, strategies, and tools available on how to effectively conserve biodiversity and to halt and revert biodiversity loss. At the European scale, those include, for example, the Nature Restoration Law or the European Green Deal. The time does seem ripe to work on the implementation of these strategies at all scales, from local to global.